Hello, Himanshu. I welcome you to my podcast. I'm really thankful that you gave me time to come for this podcast.
Thank you. This is really this is something special and new and quite honorary. Like I feel quite honored. So yeah, thank you for calling me here, Chandan.
For the audience, just quickly introduce yourself. Who are you and what you're doing and what's the all stuff going on?
Okay, so I'm Himanshu Dubara. I'm from Hyderabad, Telangana. I study in Karnataka in National Institute of Technology, Karnataka. I major in electrical and electronics engineering. Right now, I'm in my fourth year. I mostly work in work by work. I mean, I've interned at places that mostly deal with embedded and cyber physical systems, IoT, and the likes. So yeah, I'm mostly trying to learn about connected worlds, connected technologies, smart technologies, and this is just me trying to learn and improve in this field.
So, how I came to know about you? You had your nomination for some work that you submitted at the Hurling Walls Labs. I guess it was connected to some smart meters. So, what work was that, and what did you propose, and what was that thing?
Okay. So our power sector is going into the big data race. Now we're just not bothered only about how much energy we have taken, like those units. Now we move to more intuitive questions like what can be my usage or how to optimize usage for better power distribution and all of those kinds of questions. Questions that involve data, questions that involve learning, questions that involve insights. But the pace at all of this is data, which is energy consumption data. And that's where smart meters come in. Smart meters differ from traditional meters in the fact that they collect data in real time. So maybe as like you have consumption data collected one data unit per second, and you can actually see it in real time, or your utility company can see it in real time. So once you have all this data, you perform your analysis and you run your algorithms. But the problem here is to ensure the accuracy of data. Nothing, nothing works if your data is not accurate. Right now, the methods are mostly manual and lab based, but considering that in the near future almost every place is going to have a smart meter, it's not really viable to take a smart meter back to your lab and test it. It's a time consuming, and b the data loss would be a lot. So my proposal for this was to we had developed an edge machine learning based module that calibrates these smart meters in real time. It is a generic automated kind of module, so it requires no intervention from humans. There's no assumption about the smart meter, so it works generically on all smart meters. So your cheaper meters, which may not have the high level of lab testing as your industry grade meters, they can be used. This was basically for that when we did in our lab. The idea is to bring and it's plug and play. So the idea is to bring accuracy to any meter and to bring it in an automated way. So like the idea is to give it a smart twist. So you don't have to bother about manually correcting it.
Okay. So I guess last week I was talking to Chinmay Nayak, the one who actually won this Falling Walls Labs competition. So what he told me, and I guess the same would have happened with you, that they had this two slide format, that whatever
Right.
your work is, that you have to explain it into slides, which I think is actually a very smart thing to do, because we don't need to tell so many things about the background, about the introduction, and all those things. So what do you think about this format of 2 slides and 3 minutes and all that stuff?
So, I mean, okay, being in college and being in school, every time we've been told to write a lot, explain a lot, keep
Hmm.
talking till your time is done. Now, this was a very different kind of method. Here we were taught about reductionism. So the idea was to cut out all the facts that are not essential. Like this is where things differ from your conferences or journals, where you have to include everything, anything, and everything, like from the very background of your research to how it's going to go and all technical details in between. Here, these pitches are about the impact of it. So the impact
Hmm.
can be explained in like two phases. First phase is what is the issue. Second phase is what are you doing about it. So that's essentially what this two-slide format was. I mean, it was three slides. First slide was a title slide. Second
Hmm.
slide was your content, like what is your issue, and third slide is how you're solving it. So what this taught me was a very nice way to deliver without deliver content without talking too much. So we had to time ourselves. It had to be limited in 3 minutes and all of that. So that way I learned, like I myself learned what were the essential parts of my project and what were the parts that were extraneous and not uh, germane to the topic per se. Plus, this kind of feel had like this pitch had a different feel to it in that in an academic conference, all your people are targeted, that they are
Hmm.
from the same background as you. Or, I mean, in my case, they've obviously worked more than what I have worked. I mean, there were at least PhD people. But in this case, there are people from a lot of different areas. There were people who were into the business side. There were people who were industrial. So the idea was to present a topic that you think is basic, but it has to be presented in a way that everyone comes to know. So this was a new way of presenting a topic for me. So these are a few things I learned,
So
and it was a quite novel experience. Sorry, yeah,
So
go on.
this range of audience that they have given to you, that there would be someone from the business, there would be someone from the management. This is actually a very nice thing to put someone in, because then we can get the feedback from every perspective, like how your idea will be perceived by somebody who is purely into business, and how your idea will be perceived by somebody who's purely into that some other field totally different than yours. So this is was another smart move done by all involved labs, I suppose. So
Yes.
mhm.
Sorry, nothing.
No, no.
Nothing. Go on.
Okay. So as you mentioned about cyber physical systems, so let's just suppose that I'm a new person who doesn't know anything about it. So how will you explain that concept to a totally new person?
uh, Consider any, let's break it down, cyber and physical. So what are your physical systems, like anything that is not traditionally okay, any system that has physical components to it, like say your car, or it could be an automation, like it could be a building factory assembly line, it could be your house utilities, it could be electricity in your house, it could be anything that is physical, anything that is tangible is a physical system. So a physical system will perform some work. So the idea is, now that we are reducing computer size and now computers are getting everywhere, the idea of ubiquitous computing, which is everything has a computer attached to it and everything can think and compute for itself. So from this concept comes the fact that your physical systems, let's say, what if your car was able to do some amount of decision making? What if your utilities, if your electricity, your plumbing, what if your assembly line in your factories, what if they could do some amount of thinking and automation? Then that would reduce load on humans. Plus it would be a little more accurate in that they don't tire or they don't have
Hmm.
uh, silly errors or human errors in them. So this is where the concept of cyber-physical systems come in. Cyber-physical systems is essentially just attaching computing units to your physical systems, uh, giving them the power to analyze data, giving them the power to look at output and use feedback loops to improve performance. In this age of connected technology, cyber-physical systems has also expanded and mostly deals with IoT and distributed computing, so you are offloading a lot of your okay, till now a site's headache was its own. So let's say you are at a place, whatever happens at the place is your headache. But now with connected world, you could shift some of that headache and ask people to collaborate with you. So this is where so this is one more thing that cyber physical systems do. You can distribute workload, you can distribute issues, you can do so it paves for a more connected physical system. So that way it brings automation, it brings data, it brings analysis, algorithms, all of these to have like smarter physical systems. You could have an element of learning, you could have an element of like machine learning, deep learning, all your AI concepts, all of those come in. uh, the basic idea is just to make your system smarter, your physical systems, anything that you see, anything that is tangible, make it smarter by introducing computing and algorithms and connectivity that follow.
Wow, that's great. That's great. Your work at Falling Labs was connected to smart meters. But apart from this, you have also worked on smart water management systems. So what that work was about?
Okay, so I interned at a company, FluxGen
Hmm.
Engineering Technologies. They deal with smart water solutions for businesses. So the idea is this: if you knew about your consumption of water at different points of time, like at every instant, if you knew what your consumption is, if you knew your consumption patterns, then
Hmm.
you can optimize your consumption. So FluxGen develops technologies for businesses to be able to monitor their consumption, monitor their outlets, inlets, and then to be able to plan their water supply and water consumption.
Hmm.
This saves a significant amount of water. What I worked with them was on their N module, which is the module that is actually attached to physical piece. Uh, that had like it has to be connected to a server to be able to see to be able to send
Hmm.
status data of consumption.
Hmm.
So generally how this is done is now things might get a bit technical, but there is like a master controller, there's a master computer, a small embedded system that takes in data, and then it shifts to a GSM module. This is the GSM module then sends the data to your server. Now, in terms of computation, it is a little like you have like two modules and you have to have connectivities, and A increases costs, B, all those bias and the data losses might be there. So it's quite cumbersome. So there were modules available. We used a module that integrated this that had a GSM module, and it had a CPU embedded into it. So the idea was computing and connectivity in one GSM module. My job was to integrate this with their meter and to employ, connectivity mechanisms. So I was able to establish certain connections with a remote server to be able to see how and to do basic control using SMS or like TCP connections. Okay, these
Hmm.
are technical terms, but in
Hmm.
short, I was able to use the an integrated connectivity plus master controller module to be
Hmm.
able to save their space and space and design constraints to be able to optimize their space and design.
So when you talk in smart water management systems to save something, so what does that saving is the part here? Like what part you are trying to save in that case? Just the flow of water or instead of water or what's that stuff?
We don't. Okay, here's how it goes. If um, a simple example, if you just generally go about your day, you wouldn't know how much time you're wasting.
Hmm.
But if you, let's say you had an account, like let's say you had an app or someone who actually kept a register of what you are doing at what time, then you
Hmm.
might see where you're not spending time productively, and then you might next day you might actually do better.
Hmm.
So it's the same concept with water. Let's say there is someone monitoring every second and every outflow and inflow time. Like let's say it's monitoring wherever your consumption is and wherever there are wastages and extra consumptions
Hmm.
without productivity and all of that.
Hmm.
Then in that case, then you can develop uh, methods or algorithms
Hmm.
to improve upon this water consumption. So in that way, you use optimum water.
So you have also been a research intern at Samsung. So what did you do there?
I was an intern at Samsung. Mostly, like I worked with I worked with image processing on digital systems. We did Photodub. I developed a module for Photodub composition. The idea was to see, okay, Photodub composition is basically you have two images. Nowadays we can overlay an image on another. There are multiple ways to do it. Either you take the common area or you take one on top of the other and so forth. So there is a simple algorithm to do that. I had to implement it in a digital system because hardware is essentially faster. So for simpler tasks like this, if you have a small hardware module, it could go a lot easier for your display screens and so forth. Like whichever digital system you want to use it in. Uh, so I designed a module. I tested it for functional correctness, and that was it. It was a short internship, about 2 months or so.
So the thing that I actually wanted to ask you is that for a person to be in the field of research, a researcher needs to have a vision about what kind of work that they are going to do, what they want to do. So when you start a work, when you start to work on some project or something like that, so how you develop that a vision for your work?
Uh, so first things, obviously, you have to understand the why of it. Like for example, when I was working with SEI Lab, I understood it was for smart buildings and smart cities and the fourth. So that gives you a sort of motivation on why you're doing it in the long run, like in the big picture, not why as in good for my resume or good for my work. That is there, but like once you see a bigger picture, just to start working with, you start associating yourself with something big and something great. Like not, oh, I don't want to use great per se, but something that is bigger than yourself. So that way you feel some sort of an obligation to actually give more, to give for the future and give for the world and those kinds of things. Second thing is just like motivation. It has to correspond to your personal motivation. For example, like I want to work in like connected systems. I want to see a connected world and so forth. So what I worked on has the idea was for me to learn, uh, like internships were mostly to learn and to see how what the industry trends are or what the research trends are in these fields. So what my work was mostly based on was to gain some experience and interest in that field. So that way so if your work corresponds to your personal goals, like if the big goals correspond to your personal goals, then I think you have a uh, like then you have that small motivations to see how what like that way you have a direction also, like let me work this way so I will learn this and so forth. And that's about it. Like if those visions match, then you also have your personal vision, like anything. Like if you want to see yourself working 10 years from now in some place or in some capacity, then see how this focuses towards that. That's about it, I guess.
So my last question to you would be, you have been part of various groups, you have been part of various competitions and done much stuff like in NIT Kurukshetra, NIT Karnataka. You were the part of that flying club, aeronautics and all that stuff. So what is that one learning that you have got from these places that you would like to share with the with somebody who is just going to start new?
Yeah. So here's how it works. Like till your 12th standard, everything is about yourself. Like you'll be studying on your own, you'll be writing an exam on your own, your friends would be there, but ultimately it's you sitting in the exam, it's you writing the paper, it's your ranks, your marks, your college application, everything about you. And there comes this over independence where you are like, if I do my work and everything will be fine. But then I came to college, I joined clubs, I joined the Flying in Robotics Club. There are other clubs, ACM and ITK chapter and so forth. what I learned here is that when we work, like even in the real world, people look for work in terms of projects. You'll be working on project. You won't be sitting and writing a paper in real life. Like you won't be writing an exam. You'll be working on something. So there, it's collaboration that counts. So you will not have all the skills required to do a job. Nobody has. So you will have to find people who complement your skills
Mhm.
and you will have to work with them. So the one thing I learned is collaboration, where you have to work with people, you have to work with like you have to make your skills look match their skills, match in the sense of complement, and you have to work together towards a shared goal. You need to find that group of people who share a similar goal as you, who share similar interests as you,
Mhm.
or even diverse interest works, because then you both have your interests and you combine them to create something new. So the idea is just to collaborate. Like that's the one true difference I've seen from school and college. You collaborate a lot.
That's good. That's good. So with this, we come to the end of the podcast, and I'm really thankful that that you came for this podcast and you gave us time and shared your insights with us. So I'm really thankful for that.
Thank you. Thank you for having me.